So now that we've made it through the first pass of our reliability loop, once we have an AI system that's reliable, we can start thinking about efficiency. Reliability comes first because optimizing an unstable system could introduce more failure modes. Lowering cost and latency is the result of polishing a working system. So the rule is simple: stabilize behavior first, then optimize performance. Let's start talking about latency. Latency is how fast your system responds, measured from the moment the request is sent to the moment you receive the final response. Lower latency generally improves user experience and enables real-time use cases. There are a few parameters of your system that you should have in mind when you're thinking about latency. Firstly, we have model size. Generally, smaller models will be faster. Second, we have number of tokens. More tokens generally means more latency. Next, you need to consider prompt length, because that would increase the input tokens. Finally, be aware of any tool calls or multi-step change that might appear in your traces. These increase latency from the communication with external servers and additional LLM calls. When reducing latency, you generally trade some quality for speed, especially when moving to smaller, faster models. Now let's talk about cost reduction. Cost is mostly driven by tokens, generally represented as a factor per million tokens. Let's look roughly how this is calculated. Cost calculations depend on the model, but generally it's split between input tokens, which is your prompt input, and output tokens, which is your response. Long prompts, verbose outputs, and unnecessary retries all increase cost. So once you have proven reliability, you can start experimenting with your shorter prompts with tighter output constraints and with cheaper models. And we shouldn't really worry about prompt degradation because we have regression testing to help us with that. So now let's speak more general terms and talk about how model choice is another trade-off that we have to be aware of. Larger models usually give better quality, but are slower and more expensive. On the other hand, smaller models are cheaper and faster, but often less capable than their larger counterparts for the same provider. Optimization often means finding the smallest model that still passes your evaluations. You can also tune some parameters like temperature, where lower temperature can sometimes give you quicker response times and less looping if you have an agentic system. We also have the max token parameter. Lowering max tokens will restrict your response tokens and lower price. So as a recap, cost and latency optimization requires a principled approach. You compare the same task, the same dataset, and the same evaluations, and then you measure your quality scores, your latency, and your cost per request. Like we've been emphasizing in previous lessons, this makes trade-offs explicit instead of subjective, which is always what we're looking for in this type of work as an AI PM. In a more general sense, and in the practical context of real systems, there's no single best configuration. The right balance is going to depend on your user expectations, your traffic volume, your budget constraints, and also the risk to your product. Your job in all of this is just to choose intentionally.